Hi, my name is Radli bin Jeffrey. I will be presenting about radioactive decay. Next, introduction of radioactive decay. The definition of radioactive decay is unpredictable process in which an unstable atomic nucleus loses energy through radiation emission. In other words, the radioactive will decay or disintegrate into atoms of another element into another isotope of the same element. The application from first ODE toward radioactive decay is separation of variable, and mathematical model for radioactive decay is MT equal to CE to the power of negative KT. So next, how to solve radioactive decay problem? First of all, first step is find value of C and K by applying initial condition given into mathematical model. Second step is substitute value of C and K into mathematical model to make an equation of isotope at time t. And lastly, the third step is find half-life and substitute into the equation to find value of t. The problem statement for this topic is the radioactive isotope of cobalt-60 decays at a rate proportional to the amount present at time t. It has a half-life of at 7 years. If 234 grams of this isotope is present initially, how long it will take for 35% of the cobalt to decay?
Hello, I am Ahmad Asif, and for the solution, the first step is to find the expression of MT, which uses t or time as its variable. So we need to find the value of the constants in the equation. Firstly, let's look at the first column where we need to search for the value of the constant C. By inserting the initial mass 234 and time to 0, we will get the value of C, which is 234. Now let's look at the middle column in which we are searching for the mass at its half-life by multiplying half with the initial mass, which we will get 177 grams. By reinserting the discovered values in the expression where t equals to 87, the only constant left is k. In getting the k, we have to eliminate the exponent by using ln, and we will be able to find the k. By inserting all the value constants, you will get the expression which is 234e to the power of negative 7.967208972 times 10 to the power of negative 3. For the second step is finding the remaining mass of the isotope after the decay, which is 35%. Search for the 35% decay value by multiplying it with the initial mass 234, then minus the value that is 81.9 from the initial mass, and we will get the remaining mass, which is 152.1 gram. The last step is to find t, which is the time it took for the 35% to decay. By using the expression we found in step 1 and the MT in step 2, we will be able to find t using the same properties that we used to find k. Lastly, we will get the final answer 54.069489 years.
Assalamualaikum warahmatullahi wabarakatuh. Prisma and I Najmi will continue with second problem of radioactive decay. So the problem is the initial mass of a radioactive isotope is 150 grams. After 3 years, it is found that remaining amount is 50 grams. Find an expression that gives amount of the isotope at time t. So to solve this, we take the information given, which is initial mass or M0 is equal to 150 grams. Using the formula of MT equals to CE to the power of negative KT, we get 150 equals to CE to the power of 0 times K. And we get the value of C equals to 150. And then, we use the information of mass after 3 years, M3 equals to 50 grams into the same equation. And we get 50 equals to 150 times e to the power of negative 3k, and then 50 divided with 150, and we get 0.33 equals to e to the power of negative 3k. We put ln both sides to eliminate e, and we get negative 3k equals to ln 0.33. So we get the value of k, constant of proportionality, equals to 0.369554.
Hello, my name is Krisma Nelirema Anak Richard. I will continue the presentation for questions B. Determine the half-life of the radioactive isotope. The half-life of the isotope is the time when the amount left is 1/2 multiplied by M0 or initial conditions, which is 150 grams. Then we get 5540. Then we get the answer 0.5 equal to e to the power of negative 0.3695540. To find the answer t, we need to put ln for the both equations, so we get t equal to 1.8756 years. Therefore, the half-life of the isotope is approximately 2 years. Thank you.
For the conclusion, there are other applications of first-order differential equations that have been discovered and have helped humans in calculating certain situations. And as humans that are constantly evolving, it is our job to know and discover new possibilities that these differential equations might bring upon in the future. We hope that this video helped the viewers develop their knowledge of first-order differential equation applications.